Good morning. In this lecture, we are going to revise a second unit, which is electrical installation. As this unit is a theory one, everything is important from this unit. These are the contents which we discussed in the second unit. The first one is wire. We discussed what is a wire and types of wires and factors affecting the choice of wire. Coming to the definition of a wire, a single conductor or a group of conductor which may or may not covered by insulation is called as a wire. And we also discussed there are two types of wire: solid wire, stranded wire. Solid wire contains only one single core. It may or may not contain insulation, whereas coming to the stranded wire, it will have multiple strands which may or may not covered by the insulation. And the next one is factors affecting the choice of wire. The color, lettering, and also size of the wire will come into picture if you are choosing a wire for particular application. Moving on to the cables, the difference between the cable and a wire is when two or more insulated wires are twisted together will form a cable. Example for cables are TV cable, LAN cable, Ethernet telephone cable, and also USB cable, etc. And the next thing we studied is a factor affecting the choice of a cable. While choosing a cable, what factors come into the picture? There will be multiple factors: cable cost, a lifetime, permeance, accessibility, appearance, etc. We also classified the cable into four types. For the first one is a twisted pair cable. Here two wires will be twisted with each other and forms a twisted pair cable. Moving on to the coaxial cable. Example for a coaxial cable is a TV cable. In coaxial cable, the center of both wires will be at a same point. Example is TV cable. The next one is multi-conductor cable. Here the number of conductors or number of wires will be more than two. Example for multi-conductor cable are Ethernet cable. Ethernet cable have 8 wires. And the other example is a telephone cable. And the final one is a optical fiber. The optical fiber cable is a special type of cable. Here the signal is transmitted in the form of light. The core or conducting medium will be glass. Moving on to the next concept, batteries. In batteries, discussed was what is a battery, and we discussed the types of battery. We classified battery into two types: primary battery, secondary battery, and then we discussed characteristics of a battery. What are the characteristics that a battery should have? And the next thing we discussed is a construction and working principle of a battery. And finally, we compared primary batteries and secondary batteries. The definition of a battery is a device which converts chemical energy to electrical energy by using chemical reaction. Moving on to the important characteristics of a battery. These are the important characteristics of a battery: type of a battery, voltage level, on what should be the voltage level, discharge curve, how that a battery should discharge, depend these etc. All these characteristics will come into picture. All these characteristics will play crucial role in choosing a battery for specific type of application. Suppose for example, if I am choosing a battery for a mobile, the type of a battery should be a secondary battery. Moving on to the voltage rating should be 3 to 5 volts. Discharge curve, it should discharge slow, and charging curve, it should charge very fast. Capacity, or depending upon the price of the mobile, the capacity will vary. And energy density, especially mobile phone battery should have a high energy density and temperature dependence, etc. Moving on to the construction, the three basic elements in a battery are anode, cathode, electrolyte. Anode is a positive terminal of a battery, cathode is a negative terminal of battery, electrolyte is a medium in which cathode and anode are placed. And we also discuss the working principle of a battery. And finally, types of a battery: primary battery means which cannot be recharged. Moving on to the secondary battery is a rechargeable battery. Also saw the examples for a primary battery and also for a secondary battery, and this is a comparison table between primary batteries and secondary batteries. Our next concept is earthing. In earthing section, first thing we discussed need for earthing, why there is a need for an earthing. We also discussed type of earthing. The need for earthing, primary need for earthing is to protect humans or equipment from high electricity. Moving on to the types of earthing, there are multiple types of earthing, but in our course we have only two types of earthing, which is pipe earthing and plate earthing. We discussed the pipe earthing and plate earthing, and I also gave the ISI standards for the dimensions of pipe and plate and how deep we should bury the pipe or a plate underground depending upon the type of soil. And the next thing we discussed is a LT switchgear. LT stands for low tension switchgear. First, we discussed about a fuse, or what is the necessity of a fuse, what are the desirable characteristics of a fuse, and we also discussed the advantages of a fuse. A fuse is a short piece of wire or thin strip of wire which protects the device by sacrificing itself under overload and short circuit condition. And the desirable characteristics for a fuse are it should have a low melting point, it should have high conductivity, and it should have least effect of oxidation. And we also discussed the advantages and disadvantages of a fuse. The only disadvantages of a fuse is we have to replace the fuse when it operates. Moving on to the SFU, which means a switch fuse unit. This is a schematic diagram for a switch fuse unit. It is a simple panel which contains switches and fuses for each and every phase. Moving on to the next device, a relay. Relay is an element which senses the signal and sends the signal to a circuit breaker. Then the circuit breaker will perform operation, either closing the switch or opening the switch. Circuit breakers are again classified into miniature circuit breakers, molded case circuit breaker, earth leakage circuit breaker. These circuit breakers will have an inbuilt relay. First, we discussed miniature circuit breaker, construction and working of a miniature circuit breaker, and molded case circuit breaker. And we also discussed the difference between miniature circuit breaker and molded case circuit breaker. This type of circuit breaker is used in a domestic purposes, and this type of circuit breaker is used for commercial purposes. The major difference from is we can operate MCCB remotely, but we cannot operate MCB remotely. And finally, earth leakage circuit breaker. This type of circuit breaker protects the equipment from earthing, senses earth current. If there is a presence of earth current, isolate the power supply and equipment. And we compared circuit breaker and fuse, and we also compared MCB and MCCB. Moving on to the next concept, which is a power factor improvement method. In the second chapter, we discussed what is a power factor. Power factor is nothing but a phase angle difference between the voltage and current. Then the power factor of this particular system will be cos phi, where phi is equal to theta. Then power factor equal to cos theta. In simple words, power factor is the phase angle difference between voltage and current. And we also discussed the reasons for a low power factor. The reasons for the low power factor is industrial loads. As most of the industrial loads are inductive in nature, as more than 95% of machines used in industries are induction motors. So induction motor power factor is poor. So that is the reason why in industries low power factor occurs. And we classified power factor improvement methods into two types, using a static capacitor and using a synchronous conductor. In a static capacitor, the capacitors are either connected in star connection or in delta connection across a three-phase supply, as shown over here. The capacitors are either connected in star connection or delta connection, as shown over here. Moving on to the synchronous condenser. In the place of static capacitor or condenser, in the place of static capacitor, we are going to connect an overexcited synchronous generator. The next thing we discussed is a battery backup. Battery backups are divided into two types: offline battery backup and online battery backup. The block diagram for offline battery backup is this one. We have a AC supply. AC supply is given to the charger and then to a battery. From a battery, it is given to the inverter. Why there is a need for inverter? We can store energy only in a DC form. We cannot store it in a AC form. Our stored energy is a DC supply. We have to convert the DC supply into the AC supply and utilize. So if you observe, the load will be either connected to the AC mains directly or to the inverter. Suppose say if we have a AC power supply, then the load is connected to a AC mains, and if we lose the supply, there will be a delay of 2-3 seconds, and this load will switches from AC mains to the inverter. Golden type of inverters, you may observe a delay of 2-3 seconds. This is due to the delay in switching action. Online switching, the load is always connected to inverter. If you have a power supply, the battery will charge and discharge simultaneously. If you don't have a power supply, the battery will discharge and provide energy whichever stored in it. So in conclusion, as this section is completely a theory one, you have to read each and every concept. Every concept is important from this chapter.